Numerical analysis and optimization of the residual stresses distribution induced by cold expansion technique. Cold expansion technique was introduced as a method to enhance fatigue lives of fastener holes. The main goal of this work is to analyze the effect of the mandrel shape on the effectiveness of the cold expansion method and then attempt to optimize the residual stresses by searching the appropriate geometry of the mandrel. Figure 1 shows the principle of the cold expansion method. In addition to the ball, it is suggested to model mandrels with different taper degree as resumed in Table 1 and shown by Figure 2. Figure 3 shows the finite elements model developed for the simulation of the cold expansion. The ISO values clearly indicate that the residual stresses are not uniformly distributed around the hole and in its vicinity. This is more pronounced in the case of the ball, where tensile stresses are present in the vicinity of the hole at the entrance face. It can be observed that the expansion with the ball mandrel leads positive stresses on the vicinity of both sides of the hole. Better yet, Figure 5 shows that the circumferential residual stresses along the thickness are slightly uniformly distributed for lower taper. In fact, with lower taper, as 3.83%, 2.875%, and 2.3%, a significant gain in circumferential residual stresses is obtained. As a conclusion, 1. The residual stresses distribution along the hole can be optimized using appropriate geometry of the mandrel. 2. Taper degrees lower than 7.667% leads to higher values of residual stresses around the entrance face of the hole edge.